This is a Fairchild semiconductor model 6200 curve tracer, built sometime in the 1960s. This is the 6200. They also had a 6200B, and I was unable to find any documentation on the 6200, but there is some information available on the 6200B, and I was able to find a 6200B service manual, so I'm hoping that they're very similar. This unit doesn't work. It doesn't have any high voltage on it, on the CRT. I did a few preliminary checks on it and I found some leaky caps which I replaced, but it didn't help the problem. It still doesn't work. This was kind of around the same era as the Tektronix 575 that was used back in the day. Of course, the 575 was vacuum tube. This one is all solid state, except there's a few tubes in here for some high voltage, some regulation. Of course, the CRT is a vacuum tube. It has your standard controls in any curve tracer. You got your sensitivity for the vertical and horizontal here. You can control your collector sweep voltage here. It's variable, and it has some different ranges. This will measure up to 1000 volts, and then you can, of course, connect a series resistor with your collector lead here. It's got a, what I guess they call the front porch on the Tektronix curve tracers. You can put in a semiconductor in each side, and then with this switch you can switch between the two. It's kind of a copy of the Tektronix. Not a lot of information on this. Here's a look under the hood here. You can see it does have a vacuum tube here. Somebody wrote 5881, that's probably a regulator tube. Now this is the high voltage section here, and I do have the high voltage of the 6200B here, and they look very similar. They've got a pictorial here and they've got a schematic, but they don't have a board pictorial that shows all the connections on it, which I was kind of disappointed. So here is the actual supply, the high voltage supply. Now this has a dual transistor in here. It would be Q2 A and B. That would be this transistor here, and it has 6 leads on it. And I figured, well, that's going to be impossible to find, but I did find a guy selling some of these on eBay. I got 5 of them. So hopefully that's going to work. The other transistor is just a regular bipolar. I shouldn't have any trouble there. It has another device here, and I don't know what that is. If you can see it in there. It's that gold colored device there. I didn't get any numbers on that, so I don't know what component that is. That's not, I think that might be Q3, I'm not sure, but now on the 6200, on the 6200B, on the diagram here you can see it shows a regular TO3 transistor. So I'm assuming that's some kind of a transistor. I guess we'll have to dig into it a little more. Here you can see some of the caps I replaced. These were visibly leaking, and so I replaced those right away, but it didn't have any effect on it. So let's turn it on and see what happens. Besides nothing. I'm going to turn the intensity control all the way up. Okay, the gradical scale illumination comes on, so that works, but there's no voltage on the CRT here, no high voltage. So I guess we're going to try to check out the high voltage power supply, and that will be some of our first steps here. This is a schematic of the high voltage power supply, in the 6200B. So it's a little bit different than the one I have, but luckily it's pretty close. There's a few different values. But anyway, the way this thing works is Q1 here, this is an oscillator that oscillates at about, I think it's about 50 kilohertz. And then that drives this power transistor here that drives the primary of the high voltage transformer. And then on the secondary, we've got a high voltage winding, and that provides the high voltage. And then the way this works, as far as regulation goes, it uses this dual transistor package here. This has 2 NPN transistors in a single can, and by using it as a comparator, it has a reference voltage here, and it compares it to the output, and then that has drive for the oscillator here to provide feedback. What was wrong with my unit was Q1 is bad, and in my stash of old components I was able to find a transistor that would substitute for that, and that would be this transistor right here. Now I had to redraw the schematic here. This is kind of a hodgepodge mess, but this is the high voltage transformer here, which would be T1. Q3 is a power device, which, if you can see, it's kind of a gold colored. In the end there, it's mounted on a heat sink. And I was glad that's not bad, because I don't have any of those. And on the 6200B, that's a TO3 power transistor. This is Q2 A and B on the high voltage here. That would be this transistor here. Right now I'm measuring the emitter of Q1, the oscillator, and I'm getting, it is oscillating, and the good news is we've got boy, that's a nice bright CRT. Here I can vary the collector sweep voltage here. So back to life here. So now what I need to do, put it back together, and this will have to be calibrated. Another difference between the 6200 and the 6200B, my is an older unit here. It's got a vacuum tube in the regulator here. It's a 5881 according to someone who wrote that in who knows when. All these capacitors are good. I checked those. So I was unable to find a service manual for the 6200. I found it for the 6200B. Luckily, the high voltage supply is pretty close. Now on the 6200B, a lot of the other supplies, like the lower voltage supplies, are on plug-in cards. This one, it's all on one big motherboard here. So luckily those supplies are good. I don't have any documentation for this, so if anybody knows where there's a service manual for a Fairchild 6200 without the B, I could sure use one. Anyway, next step, I'm going to run a few tests on this and see how it works, measuring some transistors. I have to put it back together. It has the front porch on here that's mounted. Right now it's got, turn it here, it's got 3 binding posts here. This module here plugs into the 3, you can see banana plugs on the back. They plug in there, and then you can get access to the 2, the left and the right sockets for the devices. And I think some of my Tektronix plugins might work in this too. Otherwise I can make some. They're pretty easy to make. Here it has the from left to right here. This is the focus. As you can see, I can focus it. Boy, that's a nice sharp trace. This is the intensity, and this is the scale illumination. It's got the two bulbs here that shine through the, got a piece of felt that shine through the front bezel to allow you to see the grid. I have the collector sweep range on plus 20, the maximum, and this is of course the variable here. And as I turn it up, you'll see the voltage goes up, and on the meter here, voltmeter, I've got it across the leads. You can see as I turn it up, I can bring it up. $15 volts, and then as I crank it back down, I need to find some knobs here. They're missing on the range and polarity knobs, but I've got some into my stash that I can use for that. Well, the high voltage is working, but there's still a problem with the base step generator. And you can look here, I should be getting stair steps, and as I change the steps here, that's a wrong waveform here. So I'm gonna have to try to sort this out and find out what the problem is. Yeah, these controls have no effect. I can short the base. I'm measuring from the emitter to the base, and I should be getting stair steps. So I'll have to look into that further. Now this is interesting. These peaks here correspond to 60 cycles. These are a 60 cycle waveform, and if you look, you see a little pip there. As I change the step number, you can see it's increasing. I'm going to run up another one, and another one, and another one. So I'm getting these little pulses, but it's like it's riding on this 60 cycles. So I'm wondering if I need some filtering. This should not be 60 cycles. I should have a stair step that steps. The base step generator is somewhere on this main board here, but I don't know where it is because I don't have the manual. So I'm going to have to try to trace back from the output that's driving the base and try to figure out by measuring the conduction back between those controls and find out where we're generating our base steps here. So unfortunately on the 6200B, these circuits are mounted on plug-in cards, but this is all on one big motherboard, so that makes it a little more difficult. So I guess we'll have to go from there. Here's those transistors that were on the high voltage supply. These are pretty old. I don't have any of these, but luckily high voltage is working. That was the similar to the transistor that's driving the high voltage high tension transformer there. So I wonder if these are, no, they're soldered in. Thought maybe they were in sockets, but they're not. I noticed well, I guess it doesn't matter, there's no terminals off of here, and these are probably plated through holes, but I noticed some of these are not soldered. I'm going to check the solder joints on the bottom and see if I can find, I've got some caps on here too that could be causing a problem. Not a lot of electrolytic caps, so got all these reed relays here for the different. Very well constructed. Really impressed with this thing. Like most of the stuff built back in the 1960s, which this was built. I didn't see any date codes on any of the parts here. That'd be interesting to see if I could measure or if I could observe some date codes on any of the parts. But well, I've been going over this board and I'm seeing a lot of really bad solder joints. Here's one here. Here's one here. There's a number of them. I think what I'm going to do is touch up some of these joints and see if it has any effect before I proceed trying to decipher this board here. Well, that obviously didn't help. Oh boy, that's pretty sick looking. We have miles to go before we sleep here. Well, I touched up a couple obviously bad solder joints to no avail. So we'll just have to move on and try something else here. Boy, what I would give for a schematic for this thing. So let's put a 1.8K resistor from collector to emitter, and I'll raise the collector here, and that's acting normally, so that's what a resistor should look like. Let's try a diode. I put a 1N4007 in. I got a 3K series resistor, and I'm going to run up the collector sweep here, and that's definitely a diode. So that is working. Got a capacitor collector to emitter. Going to run up the collector sweep, and that's a capacitor, a circle, although it's kind of an ugly circle. So it's our base step generator that's our problem. So, time to move on. Got a 2N2222 transistor in the socket here, and I got a 1.8K resistor base to collector. I'm going to add some base current to turn the transistor on. So as I bring up the collector supply, there it starts to conduct. So there's one curve. Horizontal sensitivity, we got 0.1 per centimeter, so we got 0.1, 2, 3, 4, 5, well, let's see, 520 millivolts, looks like, which is normal for an NPN transistor, silicon. Okay, the scope. At this point here, this is the base multiplier. It's a multi-turn pot here, precision pot. Should be getting the stair step on there. And I'm getting stair step pattern on the scope here. I'm measuring directly on the base multiplier. So, but it seems low. The level seems low to me. So if I have the signal here, there's an amplifier, zero-step amplifier. And it looks like a test point here, although this is on the 6200B, so I don't have any of those points marked out on my unit here. But it looks like it's working up to this point. This has a switch, says normal and pulsed in the base step generator. And then in the pulse section, it just pulses the device you're testing, and it gives it a lot reduced power, so you can test it without heating it up. So now looking at that same point on the base multiplier. I'm going to hit the pulse switch now, and you can see it's turned into pulses instead of steps. So that part is working. That's normal. That's pulse. In other words, it's hitting it with, I think it's like 10% pulses instead of each step. You know, each step is constant. Here it's just applying pulses to different steps. I'm going to turn the last sweep step control, and you can see that appears to be working. It's dropping them down here. Okay, I've been probing from the multiplier, the base step multiplier, which is the multi-turn precision pot on the front, and I found the point here just by actually luck and probing. And anyway, now as I turn the multiplier, you can see the level change. Now these are the steps that I need. Okay, and so that's working up to there. So even though this diagram is for the 6200B, this transistor Q42 here, reading it upside down, this has to be the amplifier here, which is this zero step amplifier. So I know I've got the flip-flops are working, the base step comparator's working, and I know I've got input to the step amplifier. Let's see if I hit the pulse. Curious. Yeah, see when I hit the pulses? When you go from normal now to pulse, this will pulse a device with 10% duty cycle steps, waveforms anyway, so it will lower the duty cycle so you don't harm the devices. So I'm good up until here. The question is, what happens after the zero step amplifier? So I need to continue my journey this way. Well, I found one transistor. This is one of those dual package transistors that was bad. This is a 2N2920, and luckily this is the bad one here. One of the sections was good, the other one was bad, and I replaced it, but still no joy. I'm still having trouble. This particular transistor, I believe, is this one in the base step amplifier here. I've like I say, this machine I have here is different than the manual and the schematics I have, so I've had to kind of trace and by deduction rule out which transistors which. I believe this one here is in the feedback amplifier, and then this transistor here is in the zero step amplifier here. And I did that by conductivity measurements. I measured back from the multiplier pot to the base of this transistor here, and then I kind of worked my way out to the back. So I still am having trouble. I'm not getting my steps to the measurement porch here on the front, so I'll have to continue my troubleshooting. I was hoping that would fix it, but that's the name of the game. It doesn't always work. So let's move on to the next step. Well, I reached a point here that I'm going to have to stop working on this for a while. Main problem is this is the 6200, and my documentation is for the 6200B, and all of this circuitry here in the B unit are on plug-in boards on the other side of this. They got away with this main board here. So I was able to get the high voltage working, and I replaced this transistor. This is one of those dual transistors I had that was bad. It had one section of it that was open circuit. I believe the problem somewhere in the base step amplifier here, but none of the components correspond to the diagrams I have for the B unit. So this is becoming an exercise in futility. If anyone knows where I can get a service manual for the 6200 or even a pictorial diagram, it'd be great with the actual part numbers. Let me know in the comments. Unfortunately, at this time, this is just going to take too much more time to work on this. I'd have to draw this whole circuitry out if I wanted to do this, and I found that there's a lot of different values from what's in the service manual for the other unit here. So what I'm going to do, I'm going to keep looking for a service manual for this particular unit, and if I get it, I'm going to resume troubleshooting it, and I may do a second video on this. We weren't able to get it operational, although it works if you want to test diodes, but it's the base steps that's where the problem is. It's supposed to develop the stepping waveforms that steps the base through different currents, so you can measure the collector current at different base currents. Well, I hope you got something out of this. I know I learned a lot about this, although I'm anxious to get some more information. So thanks for hanging in there with me, and we'll try to get this thing fixed if I get some more documentation. So thanks for watching. See you in the next one. Bye for now.